Hello, my name is Dr. Steele, and welcome to Steele Mathematics, where lessons in Algebra 1, Geometry, Algebra 2, Pre-Calculus, and Calculus are taught. And today we are going to talk about solving exponential equations. Now this is the main thing I want you to know. If a to the nth power equal a to the nth power, then m equals n. And I'm going to show you examples of what this is talking about. All right, let's say you have 5 to the ax minus 1 power equal 5 to the 5x plus 8 power. So if that is true, that means that 8x minus 1 equal 5x plus 8. And all we have to do now is solve the equation. We subtract 5x from both sides, and you will get 3x minus 1 equal 8. Add 1 to both sides, and you will have 3x equal 9. Divide both sides by 3, and you will get x equal 3. Therefore, the solution is 3. Next example, you got e to the 3x plus 1 power equal e to the 5x plus 7 power. That means that 3x plus 1 equals 5x plus 7. So now, all you gotta do is solve the equation. Subtract 3x from both sides, and you will have 1 equal 2x plus 7. Subtract 7 from both sides, and you have negative 6 equal 2x. Divide both sides by 2, and you will get negative 3 equal x. Therefore, the solution is negative 3. So again, if the powers of the same base are equal, that means the exponents are equal. But suppose that the bases are not the same. If the bases are different, you're going to write the equation so that the bases are the same. So let's look at what this is talking about. Let's say we have 2 to the x minus third power equals 16. Well, 16 is a power of 2. We know that 16 is 2 to the fourth power. So as you can see, the bases are the same. So therefore, x minus 3 equal 4. Add 3 to both sides, and we have x equals 7. Therefore, the solution is 7. Number 4, we got 9 to the x plus 1 power equal 27 to the x minus 1 power. So as you can see, the bases are not the same. However, 9 and 27 are both powers of 3. And we're going to write them as such. So 9 is 3 squared. And we know 27 is 3 cubed. So now in both cases, we are raising powers to a power. that means we multiply the exponents. Therefore, this is 3 to the 2x plus 2. As we can see, the distributive property was applied. And then the same here. This is 3 to the 3x minus 3. So now that the bases are the same, this means that 2x plus 2 equal 3x minus 3. So we solve the equation. Subtract 2x for both sides. And we have 2 equal x minus 3. Add 3 to both sides, and you will have 5 equal x. Therefore, the solution is 5. So, before you solve an exponential equation, you want to make sure that the bases are the same. And as you can see in this instant, those bases have a common base. But let's suppose that the two bases do not have a common base. Well, first, we make sure that the exponent is isolated. We write in logarithmic form. Apply the calculator property, also known as the change of base property, and solve for the variable. And finally, use your calculator. So I'm going to show you an example of what this is talking about. All right, so let's say we have 5 to the x power equal 42,429. So what we're going to do is we're going to rewrite this in logarithmic form. Therefore, x equal log base 5 of 42,429. And of course, we use a change of base property to put in the calculator, which is log of 42,429 over log of 5. So we put this in our calculator. So let's see. This is log of 42,429 divided by log of 5. And you will get about 6.6. They want you to round to the nearest tenth. Therefore, the solution is 6.6. Next, we have 3 to the 3x minus 2 power equal 512. So we write it in logarithmic form. This is 3x minus 2 equal log base 3 of 512. And what we're going to do is we're going to solve for x, but we're going to isolate it. We're going to add 2 to both sides. And you will have 3x equal log base 3 of 512 plus 2. Divide both sides by 3, and you'll get x equal log base 3 of 512 plus 2 over 3. And we're going to rewrite this using the change of base formula. So therefore, this is log of 512 over log of 3. And I meant to say plus 2 here. Plus 2 over 3. So this is what we're going to enter into the calculator. So we got log of 512 divided by log of 3 plus 2 divided by 3. And you will get about 2.6. Therefore, the solution is 2.6. And that's how you solve exponential equations. Sometimes you have to write in logarithmic form to solve for some of them if there is no way you could rewrite the equation such that they are of the same base. I hope that you have a wonderful and blessed day.